right, let's get started. Thank you everyone for attending today's 30-minute Wednesday webinar. My name is Mike Stratton. I am a systems engineer with Verify, and I am your host. I am joined today by Dan Schmitz. Today he'll be demonstrating some of the methods we use for troubleshooting slow reports. Before we get started, though, I just want to promote our upcoming house party. It's on March 17th, 2021 at 11 a.m. Pacific time. It's if you've been to our house party or Black Party before, if you haven't, it's a 100% virtual event. Over $5,000 in prizes we'll be giving away. Video testimonials from our customers. We'll cover what's coming up on the Verify roadmap, and we'll learn about some upcoming releases such as the cloud offering, cube reporting, and chat delivery. And then Vic, Matt, and myself will go and conduct a product deep dive. Quick overview or a quick agenda. We'll get started today with an overview of our company and what we do. Then we'll jump into a demo where Dan will go over troubleshooting slow reports. After that, we'll wrap up with some Q&A. And if you have any questions, you can ask them in the Q&A panel on the bottom right of your screen. That's not the standard chat panel. There should be a separate Q&A panel in the bottom right corner. And after the Q&A, we'll go ahead and reward one lucky attendee with a $50 Amazon gift card. So make sure you stay until the end to see if you've won. Right. Quick overview of Verify. We are the preferred analytics and management solution for Cisco collaboration. We provide industry-leading CDR reporting, call analytics, customizable dashboards, UCCX real-time wallboard reporting and analytics, remote phone control, macros and broadcast, change management, as-built reporting, DN, DID, and dial plan management. We have a few different solutions available, but today we're going to focus on the call analytics and UCCX reporting portion of the software. Before we get started, I just want to announce that Verify now offers Ninja Enhanced Consulting Services, or NECS. What is NECS? Well, it's one of our systems engineers, like Dan or myself, will engage remotely on a one-on-one basis. We'll engage remotely on a one-on-one basis to provide consulting services. It can be anything from like reporting, dashboard configuration, to system monitoring. This provides a dedicated SCTU. We do all the heavy lifting. If someone needs a report, they contact us and we'll create the report for them. If you want any additional information, please let one of us know or speak with your account manager, and we'd be more than happy to go over our consulting services more in depth. With all that said, I want to thank everyone for attending, and I'm going to pass the ball to Dan.
Thank you, Mike, and thank you everyone for joining us this Wednesday. As Mike stated here, we're going to be kind of illustrating different things that we could do to better troubleshoot instances of slow reporting. I'd probably say this is our number one or number two request through the help desk. And these are the things that we would normally go through to identify what the cause is. So I'm going to be bouncing between many screens through here and running multiple commands in the CLI. When we do post this video, we'll be sure to post those commands with the video as well. So let me go ahead and share out my screen here. So I'm going to break this down into three separate topics today. First topic being, how can we better optimize our Verify report? Okay, there are other factors that go into reports possibly being slow as well. The second part of that is going to be our database optimization, or MySQL database optimization. And then lastly, the Verify service optimization. So those last two items are kind of OS related on the back end of the server. But first, let's talk a little bit about how we can optimize our Verify reports. So some things to know here. Okay, so I'm in my lab here. And the number one thing that we see here is the difference or the use of the contains constraint versus the equals constraint. When we do a contains constraint, you can see here I'm doing contains anything, wildcard capital X. That is literally going through every single record within the database for the time frame that I've got here. So I've got looks like a week's worth of calls in January. This is needing to go through every single call and see if every single one of those calls matches up to your criteria. So this is naturally going to take a lot longer than if we were to do a equals constraint. We know exactly what to look for in that cell or that table within the database. Okay, so if I change this from contains anything to equals, a 4-digit number, assuming that the MySQL optimization is all done and everything, which we'll get to later, this is going to be a lot quicker than if we were to do contains. Okay, so if I do history again here, Let me refresh. We'll see that our date time frame here is going back to the 25th. So I'll just do a quick day here. January 25th. Do 22nd through 25th of this year and apply. This is now I know on the back end this may be a little slower because I've actually set some of the settings for the MySQL optimization for the purpose of this demonstration. I've set it lower to what it needs to be, so I know this is going to run slow. But if the memory configurations are all set, which we'll talk about in a minute, and you're doing equals or starts with or even ends with, that is naturally going to run faster than a contains. So that is the number one tip that we have here. Number two thing, when running reports, right? Either on a scheduled basis or on an ad hoc basis. When you build out a report, there's a lot of things going on outside of the SQL query. Depending on if in your report you're using a grouping, like a data grouping enabled, and maybe I'm grouping by terminating end user, let's say, this is going to take a little bit longer, okay? Because we're doing now two things. We're querying for CDR data, and we're matching that CDR data up with a second query. We're doing a second Axel query to find all end users out of the call manager. And then lastly, based off of what we find, we have to create the groupings, okay? So based off of the amount of data that you're searching for within said report, that could definitely take a lot longer time for us to kind of sift through everything that we find in your call manager and then to create these groupings. So just as a point, it's very common to have groupings, but if you're expecting reports to come back within a minute versus come back within 10 minutes, right? Look at one, what are you searching for? And if it requires the need to group by something in call manager and not in CDR. So that's going to naturally take a little bit longer as well. Okay, next I'm going to show you some logs here. Now, just to kind of illustrate, actually, let me hit on one thing as well here. I'll talk a little bit about a common misconception when we talked about going out to call manager and maybe pulling all these end users out of the call manager, and if we're grouping by end user or grouping by department, right, we're having to do all that work. There is a function within the application called Cucm Sync that will most of the time allow us to do a more of a resource attentive function here. So instead of us going out to call manager every single time a search is done or every time a report is done, we have this capability called CDR CMR data processing settings. Okay, and so if this were enabled, we then have the ability to go back in and say, well, query call manager for end user data, not when you run the report or not when you do a search, but one time a day, pull this information down. And that is what Cucm Sync settings. It's a very common misconception that Cucm Sync settings has to do with the CDR processing. In all honesty, it has nothing to do with CDR processing and everything to do with pulling user-based information from call manager and storing it in our database alongside the CDR data that is being processed. So when we have that local to our server, right, if you are searching reports that have 3,000 devices or 4,000 devices, and we have to go out and match, end user profiles with those devices. If you're talking over the WAN to call manager to pull all that information, that can sometimes lead to longer time periods of wait. So if you have this information local to the server, that's going to help us if you are running larger reports. Now, by all means, if you're running smaller daily long reports, there really is no need for that. This is only if you're running like month-long reports or quarter reports and a lot of data within those reports. It's going to be safer for us to query it if it's local to our database versus the call manager. Okay. All right. So next, I'm going to show you some logs that illustrates the complexity of everything. Now, I don't want you to focus on the technicals or the verbiage of these logs because it's very confusing, even for myself, but very easily I could share this screen here. This is a typical log file from our application. Now, this is a insight.log. So this log file holds basically everything that's happening within the application. When you do a search, it's going to include what the query was. And so right here, I could see the beginning of the query is this date time range and what the parameters were if it's you're looking for all SCP devices. But I'm focusing here on a couple different things. The amount of time that it takes to go out to Call Manager and discover this information. Okay, so we see right here, it's actually querying for 3,536 actual SCP devices that we have to go discover out of Call Manager, 17,000 number partitions, 124 end user IDs, et cetera, et cetera. Okay, so while we're going out, the prefetch is very easy. That's going to say, hey, this took 1 second. That's not bad at all. But when we start looking at some of this other information here, we are determining that for the 3,000 or 3,500 devices that we're seeing that we run into something called user collisions. This basically prohibits us from determining, factually what user owns what device. This is saying that this device that we're one of 3,500 devices that we have here are actually controlled by multiple users. So for verify, which one do we pick, right? And so if I scroll down through this long, notice the timestamps on this. This is it starts at 3:13-ish in the afternoon, and it continues on and on and on and on. I could sift through these logs, and then it finally says, hey, we did not find a matching control device for this specified user. Not going to show the user's name here, but as I scroll down, this is all for one job, okay? And I know it's all by one job because of the instance in the logging, pool-2 thread 5. I know these are all part of the same thread here, and I could just continue on scrolling down here. And this is just one log file. We have up to 50 log files. So in just this one log file until it starts writing to another file, I could see that, hey, it's now 3:32 and some odd seconds. And so just within this one log file, this is about 18 minutes and 56 seconds for one report to run because of all these user collisions. Okay, so that is the culprit here in this. So really got to be conscious of when you're building out a report. Yeah, it's great to say, hey, show me calls on all my phones in my entire organization. Well, based off if we have that data local to our database, or if we're going out and querying Call Manager for that, that could very well, take a good chunk of time. So, there should be never an expectation that this should run in 2 minutes, right? That's just not ideal and not realistic, to be frank. And I can tell you that this is probably going into 1 or 2 other log files. So 18 minutes is a minimum. It's probably much higher than this to actually complete the job, right? So, with the amount of information that you have in your querying for within the report, if you're going to Call Manager or going to our local database to do the device mapping or user mapping rather, that would allot for more time. So just keep those in mind, okay? All right, so I'm going to minimize here and go back to the application here. Key takeaway here, if the more groupings that we have to discover. So if I'm building out a report and it says that this report is grouping by, let's say, terminating end user. Let me go out and start building out a new report. Okay, in my grouping statistics, if I enable this grouping, one, you're automatically going to wait a little bit longer, depending on, again, how much data that we have to query and group for you. But if I'm grouping by, let's say, in the instance of device, I'm grouping by the terminating user, and so it requires us to map device ownership to a user. Okay, so the more users that we have here, let's say we find 250 users that we have to group, and so then we associate all the devices that are owned by those 250 users, create the grouping summary table. That is then again, that's a lot of data. But to limit this, right, in some cases you say, well, I find 200 grouping options in my report. I only want to see the top 10 or 15 users, but yet I'm finding 250. Or in some cases, we have the concept of creating grouping search sets. If I scroll down a little bit further here, we have the capability of creating a grouping search set. For those of you that don't know what a grouping search set is, it's basically a second query that's ran after the primary grouping is mapped and completed, and it then limits your grouping summary results based off of that second query. So by adding a grouping search set, you're obviously prolonging the amount of time it takes to run said report as well, because you're doing a primary grouping, and let's say we find 200 options to summarize, so 200 users to summarize data on, and then based off of those 200 users, we're saying, hey, we have a grouping search set. This grouping search set's only calling for specific users out of a department. So maybe let's pretend that's 10 users out of the entire 200. Well, that's doing a second query on that 200 for the 10 users, and then we display the results as such after that second query. So that could also prolong the amount of time it takes to generate a report, okay? And then last but not least, something we see quite a bit here, something we call OOM, out of memory. And this is all revolved around what we call Java heap memory. Not to get too technical, but this is basically the amount of memory the application service uses to do all that it needs to do to generate a report. Okay, so like I said before, there's multiple components to building our report. There's the database side and its resources, and then the verify side and its own resources. So that's what we call verify resources, is the Java heap memory. And really quick, just as a pointer here, we do log all the Java heap information directly within the application. So this is going to be under System, Server, Platform. And on my lab system here, we're looking at total heap memory column. That's what is important to us. This tells me that in the configuration on the server, on the OS side, we have stated that we want to give the Verify Insight service 5 gigabytes of max memory to utilize. So, going back to that log that we showed, if you're going through 3,500 devices and got to do all these different groupings, 5 gigs probably isn't going to cut it. And so what I could do is later on, I'll actually show you how we can optimize this to increase the memory. This is probably in line with the number 1 or number 2 issue that we see, is the Insight service is just not providing enough memory for everything that customers want it to do. So we increase this max memory utilization so the application can do more at the same time. Okay. All right. Just as another point of factor, keep in mind, right, we have our reports and our call history tool. We also have things running within dashboard. So if you have a dashboard, I don't have one here to show you, but if you have a dashboard running and it's got 10 widgets, running and querying every 5 minutes or so, well, that's extra resources or extra power needed to bring back those results. And I will say, though, information in dashboard is a lot quicker because it's all summary based, right? We don't need to calculate or do algorithms to determine the call types and call scenarios and things like that. So it is quicker to get the results in dashboard. However, it still utilizes resources. So if you've got dashboard and reports running at the same time, right, the logs will tell us what's going on, but just keep in mind that that's also utilizing resources. Okay, so everything I just mentioned here, I think I mentioned 6 things here to take a look at, and we'll post this with the video when it's all done, but 6 things to look at for in verify report optimization. Okay, the next topic that we're going to be talking about is MySQL optimization. So MySQL is the database on the back end within our OVA, and 9 times out of 10 when we get a ticket saying that, hey, our reports are super slow, it takes 20-30 minutes to get the report, this is probably going to be the second thing that we look at, is the MySQL resources. Okay, so for this, I'm actually going to bring up my command line for one of my servers here. All right, and we got an OVA here, and I know that this OVA has a very large database with numerous databases. So this is more going to be for the enterprise level customers that have lots of clusters and a lot of data processing. This is what we would normally do to check the status of MySQL performance. Okay, so first thing we want to look at is on this server that MySQL is residing on, what resources do we have allocated to just the MySQL service? Okay, so to do that, we're going to take a look at the MySQL config file. All that is saved in there. So we'll go change command line prompt to the etc folder, MySQL, and then let's see what is there. Okay, so we have a file called my.cnf. So I'm just going to read this file. And all of these options here tells us how MySQL is configured, what it does on startup, how much memory utilization we're giving it to it. So that is what we're interested in seeing, and that's going to be identified by the InndoDB, so InndoDB-Buffer Pool Size. Okay, so real quick, let me see if I could find it here. InndoDB Buffer Pool Size, a lot to go through here, right here. 14 gigs that were allocated to it. Okay, so let's say this server as a whole has 20 to 25 gigs, let's pretend. 14 of which is allocated strictly for MySQL. Okay, that's fine. Next thing I need to do here, though, is to identify the size of all of my databases combined, right? So to do that, we actually need to log into MySQL. So I'm going to log into MySQL. Again, we'll post these commands here later. All right, so I am now logged into MySQL and I can run any sort of select command or check my databases. Okay, so just to show you what we got, these are all of the databases that we got, and I know this is our development cluster here. We got probably about 20 or so databases on this guy. All right, next thing I want to do here is look at, okay, well, we've got the 20 databases, but how much size or how much data are in these databases? So the next command that we always run here is a select statement. Again, we'll post these so you guys have these. If not in knowledge base version, we'll do it with the video, if anything. So I'm going to copy this command out here and paste it right in here. And so here's the sizing of all my databases in its current state. So, you know, I got one database at almost 9 gigs, there's 10, there's 11, there's 12, there's 14, there's 15. So, you know, a lot of databases here takes up a lot of space. One thing to note here is this command is telling you the amount of data, so actual records in the database, how much that exists. With any database, right, there's also indexing that takes up a good chunk of space as well. This command that we just talked about really just looks at the amount of data, not the indexing. So there's yet another command that we can run that actually tells us, it recommends to us what the InndoDB buffer pool size should be set to. This takes into account, and let me paste it in there so you can kind of read the query here real quick. Okay, so it's telling us 32 gigs. So what this is telling us, we'll take the amount of data, so the records within the MySQL database, plus all the indexes for all the databases, and then it recommends to us the InndoDB. So the recommended InndoDB value should be 32 if everything runs smoothly. And so let me talk a little bit about what InndoDB is and how it benefits MySQL. Okay, so MySQL vastly different from Microsoft SQL in the sense that it runs in InndoDB and it actually is very memory intensive. So, you know, based off the amount of storage in your databases, the general rule of thumb is you want the same amount. Well, they say about 80% of the value of however large your database is, as is for memory. So if you're running a 15 gigabyte database, you'd probably want at least 13 gigabytes allocated to MySQL only. That's not counting, you know, OS or operating system or even verify. So that's the general rule of thumb for that. And then the only other thing here, I'm going to open up another server I have here because I don't want to get into any of these databases because they are actively being used, but I've got a lab system here. And so I'll log into MySQL on this guy, and there's a couple different things that we could do to maintain this database. Okay, so I'll do show databases again. I think we've got one here, demo CDR. So if we do use and then the name of the database, demo CDR, we are in that database. And one command that we can normally run is show table status. Okay, so a little bit hard to read. There's a lot of text going on, but the main thing that we're interested in here is the data free column. Okay, so this is what we refer to as overhead. So this is extra space not required by that table. So I can see the call detail record table, which is the table that houses the majority of our CDR records, has quite a bit of overhead on it. It's got, 7 gigs of overhead on it. So what we could do is we could, to optimize this database, to shrink it and to reorganize it, it's basically eliminating that overhead space. Think of a disk defrag for your Windows machine. It's basically doing that, but for the database. Okay. So the last thing I kind of want to talk about here is the command to run optimization. Just as a note, this is service affecting. You will want to probably run this command after hours or whenever the database isn't actively being written to or a lot of data. It will put a temporary lock on the database initially and then open it back up. So the real easy here, it's we are in the database that we want to run the command on. So the next command is optimize. If I could spell optimize, and then table, and then the name of the table we know is call detail record. Okay, and then that. Okay. Just as the last pointer here, if you see this green cursor or the cursor doing nothing, that's a good sign. That means it's doing its thing. This can take anywhere from minutes to hours. Just really depends on how much overhead you have on the table, and then of course how large that table actually is. It's going to give you some space back on the drive. Another point too here is your disk drive cannot be filled to 99 or 100% to capacity. This job will not run because it's actually recreating the table structure when you do this. So there does need to be ample space on the server in order to do this. But this is going to reorganize and make everything clean again. And this will speed up your reports in the long run, right? It's going to shrink the database size that we have to look at to pull data. So, and then also it reorganizes all the indexing as well. So for any purged data, like let's say you want to keep 6 months of data online, but you are at a year. That means we've got 6 months of deleted data. When we delete the data, it's deleting those CDR records out of the database, not the indexes. The indexes remain. This optimize will go ahead and eliminate the unneeded indexes as well. Okay, so that is the last tip here for MySQL optimization. I know I am tight on time. We had a lot of material to cover here though. So I do want to give time for any sort of questions that came through. Mike, real quick, are there any questions that came through that I could potentially answer at this point?
Yeah, Dan, two hopefully quick questions. One is someone asked if, do you suggest that the sync be enabled or disabled?
Good question. So for smaller implementations, I would say anything under 1,000 phones, I would say probably keep that disabled. We want to talk to call manager live in that case. For any sort of enterprise customer, meaning numerous phones or a lot of data, I mean years of data, you'd probably want that on, right? If you're depending on what your search parameters are, if you're searching for all of your phones, right, routinely, you'd probably want to sync enabled. So it really just depends on what kind of searching you're doing and then the data size limit. Like, is it small amounts of data or large amounts of data? Large amounts of data, you want that on. Yep.
Okay, one final question. How do I access the logs? And is there a limit on how much space the logs can take up on the server?
Excellent question. So let me jump back into my lab here. All right, so any sort of application logs can be accessed two separate ways. Easiest way is right in the application. You do have to be a system administrator to access these logs. So sign in as your local admin account or a named user account with the system admin role associated to it. But you'll see the logs icon right up here. And then you can view individual log files. Everything that we showed you today was within the insight.log. And what we'll do is we'll trail and keep writing the most current 50 log files. Okay, so as I scroll down, you'll see 1, 2, 3, 4. It'll go all the way up to 50. So the larger the enterprise, right, the quicker these 50 files fill up. I don't know necessarily if there's I want to say it's a 50 meg, not 50 meg, yeah, 50 meg. I'd have to check to see if there's a file limitation for each of these log files. But yeah, we'll just continue writing. So it's whatever amount of times could be stored within those 50 log files. The harder way of accessing them, if you don't have access to the UI, is on the back end. You know, if you open up, we could do it through command line, right? We'll do a trailing log on the command line, or if you have like FileZilla or WinSCP, you could connect into the server and just copy them over to your local machine that way as well. And then a lot of times, right, we ask for these log files to troubleshoot these issues that we're talking about today, but that's how you would access them. All right, any other questions, Mike?
Excellent. Nope, that's it, Dan.
All right, very good. Well, thanks everyone for your time and patience today. I'm going to hand it back over to Mike to wrap it up for today.
All right, we're going to jump ahead. We've gone through the QA. We'll go ahead and jump to the winner of today's Amazon gift card. The winner is Jonathan Mayers. Congratulations, Jonathan. We'll have your account manager reach out to you soon. I want to thank everyone for attending today's webinar. We do live webinars every Wednesday. Our next webinar is Wednesday, March 10th at 11 a.m. Pacific time. Dan and Matt will take a deep dive into building reports using custom labels. Thank you, everyone, for attending. Have a great rest of your day.
Thanks, everyone. Bye-bye.